we will we'll share that with everyone later so you can keep track of all the fun experiments that we're going to learn. So welcome everyone. Thank you so much for joining us this evening for a little at-home science fun with the Little Shop of Physics. My name is Dakota, and I have the privilege of working with the CSU Alumni Association. I want to thank you all for being here this evening and spending your Friday afternoon with us. We have about 80 people registered for this evening, and 11 of those people are CSU Alumni Association members. And I just want to take a quick second to give a special thanks to our members. It's because of you that events like this are possible and continue to be possible while we move everything virtually. So we're really, really appreciative of all of our members here tonight. Just a little bit of Zoom housekeeping. Please be sure that you keep muted for the duration of the event. If you ask a question and we need any clarification from you, we'll ask you to go ahead and unmute. But in any other case, please remain muted. We do recommend that you put Zoom in speaker view so that you have the best view possible of all of the experiments rather than in gallery view. And please use the chat feature throughout the event for any questions or comments. We'll be monitoring that as closely as we can. I will be providing my contact information, a link to our upcoming virtual events and other virtual resources, and a link to the experiments and supplies for tonight's event. So those will be available in the chat here very shortly. And like I mentioned, the recording of this event will be available for you to watch again later or to share with any friends and family. And that link will be provided in your post-event email that you'll receive next week. Thank you again for being here, and I will now turn it over to Brian and Heather from the Little Shop of Physics.
All right, so I am Brian with the Little Shop of Physics, and I want to say welcome to everybody. And then I'm going to turn it over to Heather and let her introduce herself.
My name is Heather, and I'm an assistant director of Little Shop of Physics, and that's what I get to do for my day job.
All right, perfect, perfect. And we're going to do a series of hands-on things which people can try at home. And the theme of this is here's a bunch of stuff that you can do quickly at home because you, like us, you've been out of school, you're separated from your friends, and you're not able to do all the things that we would normally do in the summertime. So that's a good opportunity to get into the kitchen, to get into the garage, to get into the living room and do some cool science. So we're going to show you some things that you can do with everyday objects. And first, I'm going to show you one that's just like one of my favorite demonstrations ever. And this is just a quick one. It's kind of a warm up. And what I've done, and I'm going to go ahead and so I can move back a little bit. So I have a mug and I have a little nut that I've connected to the end of a piece of yarn, and they're connected together like so. I'm going to take this mug and I'm going to put the string over my finger like so, and I'm just going to drop the nut. Now, if you want to try this, here's a tip. When this thing comes down, it can hit the nut. So I want to make it so that when it comes down, it can't, because I have broken a mug that way before. But if I take this and it's just over my finger like so, and then I let the mug drop, here's what happens. That string just wraps around my finger like so, and it doesn't fall. So that's one that you can try easily. I wouldn't try it with something which was really expensive and really fancy, and I would definitely do this with your parents' permission, but I just took a mug, connected it to a nut, and I just need something which is a little bit heavy. And then I put it through my finger like so. I let it fall, and the nut swings around my finger. Yeah, I saw Kinsey was kind of like doing that. Yeah, that's it, that's it. Don't you hide, you little scamp. So that was perfect. That was perfect reaction. It kind of goes around and ties itself really tight around your finger. It ties itself really, really tight, and it won't go anywhere. So that's one to try. I would try it with something you don't care as much about. Try it over carpets and see how that goes. But for next thing I want to do is show you some things you can do on Zoom. If you're like me, you're spending way more time on Zoom than you ever wanted to. And so when the Little Shop of Physics team is on Zoom, we like to do a lot of Zoom magic. So I'm going to tell you what I did. I took my room and I took a picture of it. And I chose under the video options, one of the options is have a virtual background. And I set my virtual background to be my room. And so right now there's a picture of me, but I have a virtual background, and I said I have a green screen. And a green screen you can set to be any color that you want. So I have this piece of blue fabric, and I set my green screen color to be that color. And then I get this cloak of invisibility right here. So I can like vanish. And here's my Harry Potter cloak of invisibility right there. Except this one, like, this really works. This is awesome. I can put this over me, and you can still see my hands, but I have vanished. And I love that, the cloak of invisibility effect. It works really well if you have a busy background. And if you see my office, it's busy. And if you visit my office, it's a busy, busy, fun place. And once we're all able to get together again, I invite everybody to swing by, and I always have all kinds of cool things to show people. Now, next thing we're gonna do is this. I'm gonna choose my virtual background, but I'm gonna turn off my green screen. And what Zoom is doing is it's trying to compute, like, where is the human being? And then it kind of like shows that, and everything else, it just shows the picture. But how about if I took my little, oh, by the way, I'm gonna pin myself so that you're able to see me here. I totally forgot to do that. Here I am. So here's me, and I've got this little raccoon finger puppet. I'm gonna put the raccoon finger puppet on my finger. But if I take this and I move it off to the side, I now have my vanished finger puppet. Because the Zoom algorithms don't recognize this as a face. But it also, you can't see my finger. If I take the finger puppet off my finger comes back again. So here's my finger being eaten by an invisible raccoon finger puppet. Ah! Which is kind of crazy. And then next, you can do this with gloves. So Zoom knows that my hand is here, but if my hand has a glove on it, Zoom doesn't know that's my hand. So here's my hand. Wave goodbye to my hand. And of course I'm waving goodbye, but you can't tell because you can't see my hand. This one you can. Oh, what? Wait a minute, wait. The red one came back. That was kind of cool. That was kind of cool. So there we go. Now this hand has vanished. Oh, never seen this before. Check it out. Red hand disappears. I'm going to bring up my other hand. Oh, nope, still gone, still gone. Oh, there it is. Now my red hand has come back, but I've lost my fingers. And we're having fun playing around with that. And then I'll go back to my green screen, and this is the piece that is my favorite. If I go back and I go to choosing my virtual background and I pick my green screen, and that's one of the options, choose a green screen, and I've just picked it to be a particular color, then I've got my cloak of invisibility again. I can vanish. Hang on a second, how did I stop vanishing? How embarrassing to be doing this in front of a whole lot of people. Yeah, there's my green screen. Let's not worry about it. I won't worry about it. You saw that earlier. Everything's good. But those are some Zoom magic. Those are some things that you can do when you're spending more time on Zoom. Now, I'm going to show you another thing, which is brand new. We've never shown this to anybody. And I'm going to just get it started for you now, and we'll come back to it later. And this one is slightly... It's slightly disgusting. I'm gonna be honest about this. I got this paper, and I got this paper on the internet, and it's edible paper. And I don't know why you would need edible paper, maybe for spy craft. And you can eat the paper, and it's fine. It's made of potato starch. So basically eating that, just like eating potatoes. This is like a French fry right here. Think about this as it's a French fry.
Does this mean I could eat my own words, Brian?
Oh, yes, indeed. You could eat your words. I love it, Heather. Thank you for that. Thank you for that. Oh my gosh, that's delightful. So there's my piece of paper. What I'm going to do is this. I have two flasks, and this one has water in it. And this one has water in it, but also I put some saliva in here. So before, when I was getting ready, I was like building up some spit, and I was like spitting in here a little bit. And I can see some folks, yeah, this is a little disgusting. I apologize for that. But anyway, the really interesting thing is when you eat your food, the digestion doesn't start when it gets to your stomach. The digestion starts in your mouth, and it starts with this enzyme, and it's called amylase. And what amylase does is it turns starches, like the potato starch that makes this paper. It takes starches and then turns them into sugars. So if I take a little flask with just water in it and I put in some pieces of paper like so, okay, they're gonna go in there and I'll swirl them around. I just got little pieces of paper in the flask and nothing happens to them. Nothing happens to my little pieces of paper. But my second flask has got water with some saliva in it. And if I take my pieces of paper and I put them in here, and I'm gonna swirl this around, it actually starts to digest. And this takes a little bit of time. So when I come back on the screen, we're gonna go take a look at that and see how the pieces of paper in the water are doing versus these pieces of paper in the water plus a little bit of saliva. And actually, I'm already starting to see a difference. There's paper in the water plus the saliva. And you can see they're actually starting to dissolve. We'll come back and take a look at that later. Next, what I'm going to do is I'm going to turn it over to Heather, and Heather is going to do something which is much more colorful, much prettier, much cooler. And again, something you can try at home.
Excellent. Thank you, Brian. So what I have here, I have a pair of rainbow glasses, and some of you may have gotten these during our homecoming parade. And I'm sure you've seen how these rainbow glasses work. If I put it up here, you can see rainbows. But we thought, this is all about trying at home. And so what I'm gonna do is show you how you can make your own pair of rainbow glasses. So you can take a CD you're never gonna use again. That's very important, never gonna use again. And I got one that we had laying around Little Shop, and I cut a little bit in the inside, and then I put some clear tape over this. And look at that, I can pull the little shiny bit off of there. And by doing that, I'm left with just a diffraction grating, which is fun. So this splits light apart. So now I can have my own pair of rainbow glasses. But even cooler, you can explore and see what's around your neighborhood. You could check out the lights outside. You could check out the lights in your house. Of course, safety. You wouldn't want to stare at the sun through this. It's not safe. It's still going to burn out your eyeballs. Don't do that. As an astronomer, so I talked about this is my day job. My night job is actually teaching astronomy lab. And I love to talk about spectroscopy. So for those who really would like to understand like the spectrum that comes from different lights, you could make your own spectroscopes. And I'm gonna show you kind of my own spectroscopes plus some additional lights that I have. And they're actually below my desk because it's super bright in my office. And so I'm gonna share my screen. All right, and there we go, we're sharing there. So you can see I've got this CD. I'm gonna put that over here. I'm gonna turn on this bright light. So we've got our nice rainbows there. These are spectacular. That's just a white light. But I like to check out different kinds of light. So here I have a neon light, and you can see the neon light has different kinds of rainbows associated with it. And now, let's check out the mercury light. And I really like the mercury light because you can see distinctive different color lines in it, whereas the one, whoops, with the neon are a little closer together. And this is just kind of a neat thing that you could try at home and check out different kinds of light. So if you want, you could take your CD, and I literally did this in 5 minutes in Little Shop. I took my CD and I pulled off all the tape, and then I taped it onto the end of the tube that we had laying around, and then I just made a little slit with duct tape, and now I have my own spectroscope that you could go outside with, and you could check out different spectrum. You could even put over this part, you could put pieces of tape that you've colored on with Sharpie with different colors. See what happens. You could look through leaves on trees. You could try different things. See what absorbs light, what kind of light gets absorbed. Have some fun, try some things out. Back to you, Brian.
Oh, thank you, Heather. And I will say too, if you want to build a spectroscope like this, Heather has written up some instructions for it, and we have a page with instructions for everything that we've done today, and you can go ahead and take a look at that. And Heather did that with a CD, but honestly, I don't have CDs anymore, but I do have DVDs. And I took a DVD, and it turns out if you take a DVD and take a DVD, and you can actually split it apart into two, and the silver part goes here, and I get nice rainbows off of that, but I also get a nice rainbow off of the clear part. And this, if I look through here, I see rainbows. I see rainbows. And if I look in this one, I see a rainbow reflection, and this one is a rainbow transmission. Look at that rainbow eyeball thing I got going on. Oh yeah. And it happens because inside the CD and the DVD, there are these tracks that are laid down. They're very close to each other. And you get these lines, and the lines break up the light into what we call a diffraction pattern. So Heather did something that was all about colors. I'm going to show you something else that you can do with colors. And this is something that we're just learning about, just trying this for the first time this summer. So what I did is I made a couple different kinds of tea, okay? And I'm gonna put these on a white background so we can see them. And I'm gonna pull my webcam down so we can see those there. And I've got my tea right here. This is a turmeric tea, and this is a hibiscus tea. And I just got those at the store. And it turns out the hibiscus tea has this very reddish color. I got just plain hibiscus tea right here. But it turns out, like if you had red zinger tea or any tea that comes out looking like this, it's the reddish color is from the hibiscus. And it turns out the particular molecule that makes this color will change in the presence of other chemicals. So I've got here some baking soda. And what I'm going to do with my baking soda, I'm going to take it and put a little baking soda inside here, and so that we can compare apples to apples or compare hibiscus to hibiscus. I have a second container of hibiscus tea, but this one I'm going to put in some baking soda. And if I do that, check out the difference in color. This one stayed red, and this one turned kind of brown. That one, now, and that was a really, really rapid color change. And the really interesting thing is it's changing color because I have a difference between acids and bases. And the baking soda is a base, but I can neutralize the base. If I take that solution and I add to it some vinegar, a couple things are going to happen. One is I'm going to get some foam, because you guys know if you take baking soda and you add it to vinegar, I'm going to get some foam. But the other thing that's going to happen is I'm going to turn this solution acidic again. And when that happens, Whoa, and that was a little more exciting than anticipated. So I'm going to say, kids, if you're doing this in the kitchen, you want to have some paper towels at the ready. And I just happen to have some right here. But then what happens is the color has turned back to purple, to kind of a pinky color again. And I probably have to put in a little bit more vinegar to get it back to my original, pink. And now my office is going to smell like vinegar, which is doggone, no downside there. There we go. And I'm getting my pink color back again. And if I don't like the pink color, I can turn it back to a dark color because I can use the baking soda again. So I'm going to set those aside. And I'm going to go ahead and take this away and bring in some fresh paper towelage. So thank you for your patience with me there. And if you come visit me in my office and it smells like vinegar, you'll know why. You'll know why. There we go. And I'm going to try the turmeric. And it turns out in the hibiscus tea, the molecule that makes it change color is called anthocyanin. And it's not just teas that do that. You can also have juices. Turns out we tried pomegranate juice and we tried beet juice. And I would say, if I were you, I would go into the kitchen and just get any brightly colored beverage. And you can try this with it. So if we try the turmeric tea, we've got 1 glass of turmeric tea, and I've got a 2nd glass of turmeric tea right here. And I'm going to do the same thing. I'm going to put in some baking soda. And we should see a change in color. And you can see definitely got a color change happening there. It definitely turns darker. And you can take that one and you can reverse it and make it turn back to this light golden yellow with the untreated tea. You can do that again. And I'm not going to do that because that's going to make foam, and I've been hurt before. So I don't need to worry about that. Don't need to worry about that. So here's my thought. What I want you folks to do is I want you to get some brightly colored juices. The reds work really, really well. So we tried pomegranate juice, we tried beet juice, that worked great. Or teas, we tried the hibiscus tea, we tried the turmeric tea, try different things, try a little bit of baking soda, try a little bit of vinegar. And having tried that, if you get something which is super awesome, I would say, let us know what you've discovered, because we're just playing with this now. And we're trying some kitchen chemistry. See what you find out. If you find something really, really cool, tell us. And one of the things we're doing this summer is we're making videos of people trying experiments in their kitchens, and we could put you on a little Shop of Physics video in your kitchen, just saying. So that's something to be aware of, something to think about. We would be happy to work with any of you with that. And with that, I'm going to turn it over to Heather. I think you're muted, Heather.
You're right. Thank you for the reminder. So I was checking things out the other day, staring at my refrigerator, trying to think about not eating things out of my refrigerator. Because at this point, I think the only thing I need to be quarantined from is the fridge. So I was staring at it and I thought, you know, these refrigerator magnets I have are pretty strong. And so I picked them up and I was playing around with them, and I noticed they kind of make a zippy sound. I thought, whoa, that's kind of neat. What's going on here? So I have this cool paper. And this cool paper shows me what magnetic fields look like. So I have this donut magnet here. If I stick the donut magnet up here, maybe, there we go. You can see which way the little field lines are, because there's little bits of particles that are in there that are magnetic, so they either lay flat or they stick up. And so I can see magnetic fields. And I thought, wow, so what does a refrigerator magnet look like? And it turns out that they're tiny little lines only on one side. So in Little Shop, we like to do things bigger because bigger is better. So I went to the store, went down to the office supply store, and I got these cool printable magnets, so you can actually buy these printable magnets yourself. And I said, well, wow, what do these things look like? And these, you can see, have the little magnetic field lines all lined up. And it turns out only one side is magnetic. This side, not magnetic at all. So what it is stuck in here, they look like little horseshoe magnets kind of sticking out on this side, all lined up along this way and down this way. And so they make a really strong magnetic field on one side, but not at all. So if I try to stick these two together on this side, nothing happens. But if I stick them together on this side, it actually takes a lot of force for me to pull them apart. And so you could experiment with your refrigerator magnets and kind of see which way do they like to stick. Is it easy to pull them apart this way? Or is it hard to pull them apart in the other direction? So try it out, see what you find.
And Heather, I might say too, with the magnets, they only stick on one side. They don't stick on the other side. That is awesome.
Yeah, we talked about that.
So that's something that people could easily try, just trying to stick your...
Good point.
Excellent, excellent. And next, I'm going to do some stuff with static electricity. And I'm going to do that. Oh, actually, you know what I'm going to do first? I'm going to bring back the flasks. Here was the flask that had the paper with the, this had saliva in it, and the paper is now completely digested. And it was digested by the saliva. Here's the one that just had water in it. And you can see the paper is transparent, but it's still very much together. But in this one, this paper has been digested, and it's been digested by a particular enzyme in my saliva called amylase. Now, here's another way that you can try this if you want to. If you take something which is really starchy, like a cracker or a piece of bread or something like that, and eat it, but instead of taking it and chewing it and swallowing it, just put it in your mouth. And what's happening now is that amylase is doing that same thing inside my mouth. This is dissolving. And now it's kind of gone. And as it dissolves, something really interesting happens. The taste changes because it takes the starches and breaks them down into smaller molecules. And the smaller molecules are sugars. So it's dissolving in my mouth and it's turning kind of sweet. So if you try it with a cracker, put a cracker in your mouth, just let it dissolve. It'll start to turn a little tiny bit sweet. And what's actually happening is your saliva is actually starting to digest it. The digestion starts long before anything gets to your stomach. It starts in your mouth. Now, if I want to make static electricity, oh my gosh, she's got 2 pop cans right here. Kinsey does, which is, oh man, she's ready for action. And pop cans are cool because one, they're really, really lightweight. But the other thing that's cool with pop cans is they're made out of metal. So I have a pop can here. I'm going to put it on the table. And what I'm going to do is I'm going to make an invisible force that attracts it. The way I'm going to do that is this way. I took a piece of plastic pipe And then I have a little stretchy glove. These are the same stretchy gloves that I used for my Zoom magic demonstration. Put my glove on, and I'm gonna just rub it on the pipe. When I do that, I'll show you something here. I can actually hear it start to, I can hear little sparks. I'm making some static electricity. So I'm making this very, very sparky, very, very sparky. And if I get enough sparks, it actually makes my headphones make noise, which is kind of cool. And then I'm gonna take this little plastic pipe, I'm gonna put it near my pop can, and it pulls it toward it. And I don't touch it. I don't have to touch it because the force of that static electricity happens at a distance. And if I take two pop cans and I put this between them, they both get attracted, but then they're both going to get a static charge. Oh, and I'm not seeing that, so we'll pretend that didn't happen. We're just going to do one pop can. One pop can. I can kind of like zoom it in here. Another thing that you can do this with, and I've done this at restaurants before. I can say like, bring me a styrofoam cup. Bring me a styrofoam cup. And the styrofoam cups are nice because they're really lightweight and they roll around like so. I'm going to take that styrofoam cup and I'm going to rub it on my glove. And this works great in the wintertime if you have gloves, but if not, you can also rub it on your hair. So I'm rubbing like so, and the cup will build up a really good static electric charge. Then what I do is I bring my hand near it, and I'm using, it's this invisible force. It's like, I'm making this cup come towards me. Come on, cup. You must respond to my awesome power. And you can pull this towards you. Here it comes. All right, we'll get more staticky. Oh, by the way, too, if you're not having so much static electricity, that's because in the summertime, we have problems with humidity. So what I'm going to do next is dry everything off. I'm going to take my blow dryer and take my little glove and put it over top. And then if I turn the blow dryer on, get my hand popping up. Oh my gosh, and I see the liggets. The liggets are doing some static electricity. Oh yeah, I see, and one of you is wearing tie-dye too. I see the tie-dye. You're showing the colors. Thank you for that. Thank you for that. But if you're not getting static, when some folks mark Jim and Sue, I see some static electricity action happening there too. Humidity is the enemy of static. So if I take it and I dry off the static and I take my cup and I put it on the table, oh yeah, check it out. It's being pulled to my hand by this invisible force. Now, if you don't have plastic, if you want to do some of this and you don't have a plastic rod like I do, I just got this PVC pipe, but it's Little Shop of Physics. We have all kinds of stuff. You can also just get stuff out of the recycle bin. So here's a nice plastic container I got. And there's another plastic container that I got. And the really interesting thing is these two things charge up oppositely. So there we go. Got some static. What I'm going to do is take my cup, get it nice and chargy by doing some rubbing. I'm going to put that right here. And then I'm going to take my white container and get that charged up. Oh, that pushes it away. What? Those two don't like each other. They push each other apart. But now I'm going to take my clear container I'm gonna charge that up. Clear container, what? Pulls it toward it. Oh, so I got a little opposite sign of charge thing going on. One, the clear container pulls it, and the white container pushes it. And to keep that going, I'll have to continually recharge things. Man, Kinsey's got some food, it looks like, right there. I saw a snack come in there. I think you need to share that. You have to like put that through the camera. I think that works with Zoom. I think you can share snacks over Zoom, can't you? Oh yeah, that's it. That's the ticket. Someone's sharing us. Oh, more snacks being shared over Zoom. Thank you for that. Thank you for that. And on the Liggets, you guys got a green screen thing going on. One of you keeps vanishing. The young lady over to, oh, that is awesome. Look at that Zoom magic happening. That is delightful. That is delightful. So there is some things with some static electricity, and that's all stuff you can try at home. And my advice, pull the gloves out, use your blow dryer, get them nice and dry, and then just pull things out of your recycle bin. I just went to the recycle bin and I just got a couple of different plastic containers out. We were rolling things on static electricity, and as the Liggets are showing, you can also, oh my gosh, you're also doing Zoom magic. You're making your hands disappear as you're doing this, which is delightful. Doggone it, we got some creative kids going on here today. This is fantastic. What I'm gonna do next is I'm gonna turn it over to Heather, and Heather's gonna do some fun with bubbles. And what Heather's gonna do is she's gonna show you a recipe for making some truly awesome bubbles. And if you can make like the best bubbles ever, you can do some really, really awesome things with them. So over to Heather.
Thank you, Brian. Cool. So we did this awesome recipe, and basically what it is in here is 2 parts water, 1 part soap, and I just like to use the clear dish soap because it just looks nicer, and then actually 1 part Caro syrup, and that's kind of a sticky bit. But the neat thing is, like, bubbles are all about making sure that your water doesn't evaporate. So the soap gives it kind of like a water sandwich. You get soap, water in the middle, and you get soap on the other side. But then the Caro syrup helps with keeping everything together. But the neat thing you can do is you can blow bubbles. I'm gonna point this down here, and I've just got a piece of felt. I'm gonna use my reusable straw here. Oh, that one popped. And on here, maybe, hopefully, zoom that in, and you can see you get different colors associated with things, because what's happening is that bubble sandwich is getting thinner and thicker in other areas. So that soap is trying to hold everything together, kind of bond the air, bond the air to the water and spread it out. And then the Caro syrup is keeping it from evaporating. Let's try that again. And so you get these thick and thin spots, and you get, ooh, beautiful colors. And we experimented with a couple different recipes, and you may find, hey, I tried this and it worked better with more Caro syrup. Or there might be a particular kind of soap you find works even better. Ooh. And bubbles are a great thing to play with during the summer, I think, because, you know, it's all sticky and gooey, so you can go outside, play around with this. But the neat thing that you can do with the felt that we found was more difficult to do with the paper is the bubbles like to stay on it. And that's because they're actually, it's not absorbing the water part of things. So it's not making it evaporate. So they kind of live a little longer. And the neat thing is you can actually make artwork with this. So you can get beautiful colors on your bubble. And something that we found that I found a little difficult to show you all, but you could certainly try it. Let me get bubble going. Is that because the bubbles are made of water, you can actually take a squirt gun and shoot water right through your bubble. And in fact, if you have a bubble in a hoop, you can pour water through it and it won't break your bubble. So that's kind of neat. I encourage you to go out and experiment with that. You could do some artwork. Earlier I was playing around with bubbles, and you can see that one particularly, it's nice and colorful. And this one here. So this would make for great art. The other cool thing you could do, because these bubbles last so long, is you can juggle them. So I'm gonna go ahead and I'm gonna get, this is an oven mitt and it's made out of fleece. So it's hydrophobic, so it doesn't like to absorb water. It kind of repels it. And if I get a bubble going, you can see I can actually juggle and bounce my bubble. And you could see, you could do one bubble and see how long you and your friends, you could even do this physically distanced from one another. You could blow a bubble and bop it over back and forth to each other. See how long you can get it going. And you can even experiment. You could say, oh, okay, so this works, but then does my shirt work? Let's see. Oh, no, my shirt does not work. You could try your pants. You could try hats. You could see if your hair works, although it might get a little sticky because there is Karo syrup in it. But experiment. You could even get out, I've seen it where you get out a piece of rope and you hang it across a hula hoop, and then you can pull the bubble across your hula hoop, and then you can make giant bubbles. I would highly recommend working with your parents on doing this and doing this outside, because it is extremely messy and kind of sticky, but it's something fun to do, particularly if you're going to hose yourself off after a hot day. But experiment. We encourage you to try different bubble recipes. See if a different kind of soap works better. And whatever you discover, we love to hear about it. Please send us an email at Little Shop of Physics and share what you learned.
And Heather, let me just, the recipe was 2 parts water.
2 parts water. Here, and I'll even type it in here.
2 parts water. 1 part soap.
1 part soap.
And then
1 part Karo syrup. Oop. It wants to autocorrect. It doesn't like that.
Okay. And you get these amazing colorful bubbles that you can juggle, which is fantastic. If you want to know why the bubbles make colors, well, you'll just have to come to Colorado State University and take my physics class, and we'll talk about that. We'll talk about that. And I want you all to come join. And actually, that has to do with how light interacts with the 2 different sides of the bubble. And now I'm going to go ahead and show you one more demo that's related to how light reacts with different things. And here's something you can try at home. And this is kind of a bonus one that we didn't even put on the sheet. So I have this little clear dolphin here, this little clear dolphin. It's made out of glass. And it turns out if you have glass figurines, they're typically made out of Pyrex glass. Now it's clear. So how come we can see it? I mean, light goes through it. Light goes through it. But when the light goes through, it bends when it hits the boundary between the air and the glass. And it also reflects. And so you can see a little bit of me through there. You can see the colors. And you can also see some reflections. You can see some shininess. So we get what we call refraction. That's the bending, and reflection. Well, there's a number that we use that characterizes how much bending you get and how much reflection you get. It's called the index of refraction. And it turns out the index of refraction of the Pyrex glass is exactly the same as the index of refraction of Wesson brand oil. And it just happens. I should get like a product placement kind of like thing. I should get like money from the Wesson people for this. But I'm going to take this little Dolphin. I'm going to put it inside this glass, and I'm going to turn this down so that you can clearly see. Here's my Dolphin in the glass, and you can see it. And then I'm going to take some oil, and I'm going to slowly pour it in because I want to avoid having any bubbles. So here's my Dolphin inside the glass. And I'm going to go ahead and pour in some Wesson oil really slowly so I don't get any bubbles. And what happens is it's as if it vanished. No more Dolphin, no more Dolphin. And you can see it's still there if I lift it up. So here's the Dolphin's cloak of invisibility. Now, you can try that if you have like little glass figures. This will typically work. This will typically work. Oh, by the way, I want to mention something else. Check out my shirt, Little Shop of Physics. Look at it through the mug. Now it's backwards. Got another light thing going on. It'll make the light backwards. That's because the light is bending when it hits the glass and the oil, but it bends the light exactly the same. And so my Dolphin apparently vanishes. Now, what you can try is you can try different fluids and different kind of clear objects. And it turns out you can try oils, you can try corn syrup, like if you've got your corn syrup out to make your bubble solution. There's certain kinds of clear objects which will vanish nicely in corn syrup. There's some that will vanish nicely in different kinds of oils. And so that's another thing that you can try. So we started our sequence of demonstrations by showing you how to make yourself vanish on Zoom. And here's a way you can make something vanish. And this is not using computer magic. This uses physics magic right here. And this is super awesome. And as many times as I've seen this, I still find it incredibly magical. And this is something absolutely that you can try, absolutely that people can try. We've got a little bit of time left in our session. And before we go, I want to do two things. First off, I want to say thank you to Heather for working with me to put all this stuff together. Heather is like super awesome. And one of the great things about working in Little Shop of Physics is I get a chance to work with some awesome people. And Heather's a current CSU employee, but she's also a CSU alum. She's a RAM. Yes, back in the day, Heather was a student at Colorado State. That's when we first met, back when she was a student, and now Heather has come back. And since I want to say thanks to the Alumni office for making all this possible, for connecting us with people, because it's really, really fantastic for us to be able to do this. So thanks to the Alumni Center. Thanks to Heather. Thanks for all the people who took part. So I want to say thank you to so many people. This is the most fun I've had in a long time. But then we have a couple of minutes, and I want people to tell us, and you can tell us in the chat, if you have any questions, if there's anything you'd like us to try, or if there's anything you've tried that you want to share. So before we sign off, we'll take questions or see if you have anything you want to share.
And while we're waiting, the thanks right back to you, Brian and Heather. This was wonderful. It was great to partner with you on this, and we really, really, really appreciate it. So thanks so much.
Our pleasure. All right, I'm watching to see if anybody, I see Shobanine, is that pronouncing that right? She's got a little Zoom magic going on. And then if folks don't have questions or don't Oh, can I show my density bottle? Heather says. Yes, yes. Heather's got one more cool thing to show folks. Maybe then we can, and then we can take it out with this. All right, Heather. And Heather, you're muted.
Man, it's because I like talking all the time, so I'm better off muting myself most of the time. So, but I have this thing we call a density bottle, and what this is it's rubbing alcohol in salt water, and we've colored it with if I hold it back, there we go. Now it's not so bright. We've colored it with highlighters. So we took the highlighter apart and squeezed juice in there. And turns out some highlighter juice is alcohol soluble and some is salt soluble. And now if I shake this, it mixes all up. But the neat thing is the salt water and the isopropyl alcohol don't like to mix. So they actually separate out, and you can see I have like a couple beads in here. And it's kind of fun. You could see what is the density of different plastics. So which plastics float in the layer in between, which ones sink, which ones float on the layer of alcohol. So you could give this a try. This is super easy to do. Basically, I start off with just rubbing alcohol, and I add salt, and typically the isopropyl alcohol you get is 70%. So that means it has 30% water in it. So if you add enough salt, you eventually get another layer. So give it a shot.
Awesome.
Try it at home.
Thank you, Heather. And I see a question is coming from Jonah. We tried to do static electricity, but it didn't work. My sense is it could be a question with the humidity. So I'm going to say try a blow dryer and get everything nice and dry, because like I was having the same problem earlier today. And when you hit it with the blow dryer in the summertime, when it's so humid, it's going to be, the static electricity is going to be dead in 1 minute. You only get 1 minute of experimentation. If you try it in the wintertime, knock yourself out. You got hours. You got plenty of time because it's much, much drier, as those of us who have lived in Colorado know. I want to thank everybody again. And I would say, oh yeah, we'll try that. Awesome. Jonah, give it a shot. I would say, even if you have questions after we've signed off, one of the things with Little Shop of Physics is we're right here in town. We're your neighbors. We love to hear from people. So write to us. And I see in the chat, there's an address. We have a page, which describes the experiments. Today we had a couple of things that weren't even on there, like the disappearing dolphin wasn't there. But we're going to go ahead and make a link where we explain all that. So we're going to go ahead and put all the different pieces in. So everything we've done today, you can refer to later. Give us the weekend to make that happen. Speaking of the weekend, it's Friday. I hope everybody has an amazing weekend. I'm going to put everybody on gallery view. And what do you say we all take this out by waving goodbye? Thank you all so much and for spending the time with us. Happy sciencing, and we'll talk to you later. All right, and Dakota, thank you for giving us a chance to do this.
Our pleasure. Thank you so much. We really, really love the opportunity, and we'll share out. I am going to send you an email right now, but if you could download the recording and then just throw it up on Google Drive or somewhere. It's probably too big to email. And then once it's up on our YouTube channel, I'll share that link with you and you can share it as widely as you'd like. And then we have a post-event email that will go out next week to everyone. If there's anything specific you want us to include in that, we're happy to do that too.
Just a link to the page with all the stuff. And I see people had looked at the page. People were ready, man.
That's awesome.
That was really awesome.
That was really cool. Thank you, Dakota.
Yeah.
Yes, both so much and have a super weekend.
Oh, you too.
All right. Bye.
Bye-bye.